Hello and welcome. You are here for the SUSE and Ranch Community Global Online Meetup for Kubewarden. My name is Robert Sirchia. I am your host. I'm from the SUSE and Rancher community, and I am joined with a handful of individuals from our Kubewarden team. You'll see us all on screen right now. We have Flavio, Rafa, and Victor. Our two presenters will give a deeper introduction to who those are in a minute. But I'm going to turn the stage over to Flavio because he's going to present and kick us off with this Global Online Meetup of Kubewarden.
Sure. Thanks, Robert. So, yep. Welcome to everybody. We are really excited to be here and really looking forward to exchange feedback with any of you. So just some quick introduction, what to expect from today meetup. So we will give you an overview about what is Kubewarden, and then we will go into a deep dive demonstration of Kubewarden. So about ourselves, so I'm Flavio. I've been working at SUSE since a long time. I cover different topics and technologies. Kubernetes is one of them, Linux containers. And now I'm working on this project called Kubewarden in my spare time. I'm busy with my aquariums. I try to build up things with Raspberry Pis and such, and I love running and doing other activities. Rafa, what about you?
Yeah, my name is Rafa. I'm a senior software engineer at SUSE. And well, as you might have guessed, I love to play with Kubernetes, also with distributed systems and programming languages in general. I also would like to be a ping pong player, but I'm actually pretty bad at it. So I just have fun with it. So yeah, that's it.
Cool. You have seen him on camera before. Now he disappeared, but he's around helping us today. Victor is a member of Kubewarden team and is going to help us with questions and such.
And speaking of questions, if I might interject, I totally forgot to mention how to ask a question. There's a button on the and apologize, Flavio. There's a button on the bottom right-hand side. It says "Ask a Question." Feel free to ask a question in there. We can upvote them, downvote them, and we will bring them in. And when it's the Q&A time, we'll throw out a couple polls, asking whether you knew or not. There's a chat box there. Feel free to say something nice if you feel comfortable. Let us know where you're from. I like to tell my kids who got to talk to people from around the world, and then engage with the community with that green button right below, and it'll say "Join the SUSE and Ranch community." I forgot to say that during my introduction, so sorry, Flavio. Continue.
No worries. Thanks. All right, so let's get started with Kubewarden. So Kubewarden is a project which operates in the security space, and I would like to start by introducing some data coming from a survey. This survey was done by VMware earlier this year. It covered different topics. It's a really interesting survey. I highly recommend you to look into that because there is a lot of good stuff in there. When talking about security, it is pretty interesting to see that the top concern about people when it comes to Kubernetes security is to have a way to enforce policies across multiple Kubernetes clusters, or even inside of the same cluster, because there are many people who share a cluster with different teams inside of the same organization, and so the challenge is to find a way to propagate these policies across all the different clusters and namespaces. And these policies are not just about security, preventing people from doing dangerous things, from taking over your cluster, but these policies are also important in order to achieve compliance. And so this is an interesting challenge, and I personally think that the only way to take that is by embracing the concept, the philosophy of policy as code. So in the same way as you are managing your workloads using code with Kubernetes, when you define your workloads at deployments and so on, in the same way as you are defining your infrastructure as code eventually with Terraform, CloudFormation, and similar tooling, we can do the very same thing also with policies. And actually, Kubernetes has already some aspects about security that are handled as code, with policy as code. So you are all familiar, I guess, with role-based access control. We also have pod security policies, which are now going to be dropped and replaced with pod security, which is, again, policy as code. and we have networking policies. And what we are going to focus today are admission controllers. For the ones who are not familiar with what admission controllers are, they work in a really easy way. So they're pretty simple to understand. They receive as input some object to evaluate. This object is a description of something, of an event that is about to happen inside of a Kubernetes cluster. Like, for example, Rafa is trying to create a pod inside of a certain namespace. This generates an event. And the admission controller, if interested in this kind of events, is going to look into that, and with some business logic is going to decide whether this request, this event is going to happen. So this is acceptance. So we accept this event that is about to happen, and the event, the creation of a pod, actually takes place. Or it can reject that because of some policy that is defined inside of its business logic. Or last case, it can accept it, but the final object created inside of a cluster is going to be different compared to the one that the user initially submitted. So for example, as an operator, I want all the pods running inside of my cluster to have some resource limits set. And what happens if, let's say, Victor tries to create a new pod, but he forgets about setting those limits? I can, as an operator, define a mutating admission controller that just adds some default values, so Victor doesn't face an unexpected rejection of his pod creation. And I, as an operator, I'm happy because all the workloads have resources set, and I can put some quotas and build on top of that. So this is how everything works. And Kubernetes comes with some admission controllers that are bundled inside of it, like literally inside of the API server binary, but they cannot be used to cover any possible case scenario that you might be facing. And because of that, there is a way to extend admission controllers, and this is what we are talking today about, which are dynamic admission controllers. They work in the very same way. They're just running outside of the Kubernetes control plane. And they can be used to, bring whatever policy compliance check you have in mind on top of your Kubernetes cluster. So before looking deeper into all of that, one last look at some data. Again, this is another survey, this time from Reddit, and it's a fresh one as well. And this is about who is expected to take care of security in the Kubernetes space. And what is relevant over there is that there is a new trend. So if you go back in the IT industry some years ago, you would have found just one team, the security team inside of a company, focused on this topic. But nowadays, the expectations are different. Everybody using Kubernetes is expected to contribute to the security of the workloads that are being deployed on top of it, which means that more people are expected to write policies. And so what we decided to do when looking at the current state of the ecosystem of Kubernetes and policy as code, we thought we can provide a better user experience. We can provide this project called Kubewarden that can simplify the process of creating policies, maintaining policies, and delivering policies. How did we do that? Let's take a closer look at that. So let's start by looking at policy authors. These are the guys, DevOps, developers, security experts, who are supposed to write the policies and to maintain them over the time. What we want to achieve is to allow them to write and maintain policies with less efforts compared to other solutions. So instead of learning a DSL, a domain-specific language just for policies and security, why can't we, for example, reuse our existing knowledge? And for example, this is a concrete case of the validation policy, which is written in Go. So if your team is familiar with Go, this looks like regular Go code. I don't want to dig too much into the details. We can do that afterwards if you want. I would be super happy to do that. And this is a policy which is looking at the ports that the service is trying to use. And if a port is denied, the service is not going to be created. So if you are familiar with Go, that's fantastic. But what if you are more familiar with other programming languages like Rust? Well, we got you covered. So again, this is another real example of a validation policy, which is looking at the security context of the container and taking a decision. And the same applies if you are more experienced with Swift, for example. You can write a policy, a validation policy, which in this concrete example, it is looking at the container runtime class and making some decision. So what I'm trying to stress out is that we really want to handle policy as code with, like real, regular code that you would write on a day-to-day basis. And there is a nice advantage in doing that. You can tap into the ecosystem of these programming languages and consume whatever is already available over there. So you can, let's say you have to write a policy that does some semantic versioning check. You can go and find a library inside of the Go ecosystem and just consume that. And at the same time, we as authors of Kubewarden, we can simplify the process of creating policies. So for example, this is a mutation policy written with Kubewarden using Rust as a programming language. I don't want to dig too much into all the details, but I want to highlight this single line of code. Over there, you can see that we are using a high-level function that we provide through the SDK in order to produce a mutation request. And so by doing that, we are hiding a lot of complexity from the policy author, because the Kubernetes API server is expecting mutation responses to be formatted in a really specific way. And we don't want to put the burden of learning how to do that and creating a specially crafted object. We don't want that to be, the on the plate of the policy author. We take the pain away from them, and we just provide an API where you give to us the object as it is supposed to look like at the end of the the war reconciliation, and we just talk with the API server using the language as in the format that the API server expects. Also, there are other tasks that we can simplify for you, like providing you a way to customize policies so that you don't have to R-code values inside of them. So this is a policy that, for example, is looking at labels inside of workloads, and it has a list of labels that are not allowed, a list of labels that must be specified, and a series of labels that, when specified, they have to respect a certain pattern. So this is, however, just half of the problem when it comes to to configuration of policies. What happens if, for example, an operator by mistake specifies that a certain label is both denied and mandatory? This is a conflict. This is something that leads to unexpected results. So because of that, what we implemented and what we offer to our policy authors is the ability to write validation code for the settings of policies. In this case, we are looking, for this specific conflict. You might be saying, labels, it's pretty easy to, yeah, it can happen. I can mislook something, but this is easy to spot. But, there are other policies that are, for example, operating with network ranges. And here it's easier, to introduce mistakes when expressing those ranges or port ranges, all of that. And having this kind of validation offer to the author, we think is pretty valuable. Also, to wrap it up for the policy authors, by using regular programming languages and treating policies like real programs, we have a series of advantages. For example, you can see here in this screenshot highlighted that we have a policy, and this policy is written in Rust, and you can understand that because as part of the build process of it, we are also running some well-known linter for Rust. So what does it mean? Policies are extremely powerful and hence dangerous. You have to be, really careful about what you're doing inside of policies. And so the act of writing policies using a regular programming language allows you to have more people able to review the policies to understand what they are doing. It allows you to tap into the ecosystem of the programming language, not just for SDKs and such, but also for linters. best practices when it comes to coding. And so that allows you to be able to set a high bar for the quality of your policy, and using the same tools and the same conventions that you use for your regular applications. Also, it becomes pretty easy and natural to plug policies into CI and CD systems. Here you can see a policy which goes through the usual steps of, releasing software. So running unit tests, running end-to-end tests, and pushing artifacts somewhere. So again, policy as code for us means to really treat policies as real code. So you might be asking yourself, how is that done? Well, let's see the secret behind all of that. And the secret is WebAssembly. So for the ones who don't know WebAssembly, I'm going to give you a quick introduction. WebAssembly is a binary instruction format that was initially created just as a way to extend the browser. But it is really interesting, and it is now being used also outside of the browser, like we are doing and other people are doing together with us in this bleeding edge scenario. So WebAssembly has many interesting features. First of all, is Polyglot, which means that I can write a program like our policies in Rust, Go, Swift, whatever. Then I build this program, and instead of having a binary built for Linux for the Intel architecture, I end up having a binary which is a WebAssembly module. This module, this binary, has some pretty interesting capabilities. First of all, it's super small. A policy written in Go is 300 kilobytes. One in Rust is way more, 1 megabyte and a half. But this is, I'm being hilarious. I'm being sarcastic. This is nothing if you think about the size of container images. So this is really, really small, fast to distribute and such. Also, what is really exciting, at least to me, is the portability of WebAssembly. So WebAssembly, it just needs a runtime in order to be evaluated, to be executed. Originally, as I said, the runtime was just the browser, but now there are also other kinds of runtimes that can take a WebAssembly module and run it. The interesting thing is that at runtime, the module doesn't care about the operating system or the architecture which is sitting underneath, which means that as a policy author, I can build my policy on an Apple Silicon machine and then push it and run it without any change on top of my Kubernetes cluster, which is using Linux on Intel as operating system and architecture. So WebAssembly is really built once and run everywhere. Also, given that WebAssembly is something that was designed for the browser, security has been at the center of WebAssembly since its beginning, because the browser, as you know, it has a huge attack surface, and so WebAssembly as a language has been designed with some limitation in order that ensure that certain type of vulnerabilities, attacks cannot be performed or have a really limited impact. And on top of that, there is also the runtime isolation. So here you can see that all the WebAssembly modules that I'm running on my machine, they are isolated from each other. They cannot interact with each other, but they cannot also interact with the host. So you can see that as kind of, containerization. And you can put many layers, as it is always recommended with security. So which is exactly what we're doing. We are taking our policy server, which is the component which is evaluating WebAssembly. We are running that inside of a container, so first layer of isolation. And then inside of our policy server, we are running our WebAssembly policies, which are then isolated through the sandboxing of WebAssembly. So sandboxes inside of sandboxes with no performance issues at all, in case you're wondering. Now, we spoke about the policy authors. We looked a bit into WebAssembly. Now I want to wrap it up and talk about operators. So again, for us, the mantra is to not reinvent the wheel, to try to reuse whatever people already expected to use, not just policy author. We have seen that with regular programming languages, SDKs, tooling, and all of that. That applies also to operators. So we think that the act of distributing policies can be hugely simplified. In fact, our policies are stored inside of container registries, side by side with with your container images, which means that you don't have to come up with new processes or tools in order to distribute policies geographically. You don't have to find new ways to secure, the policies, because whatever you have already in place for container images, it applies one-to-one with no change to Kubewarden policies. Also, we think that when it comes to runtime operational aspects, policies should be treated like any other kind of workload. We should expect them to be observable like any other kind of workload we already are running, which means if something goes wrong, or if we have the need to understand better what is happening inside of a cluster, we can hop into Jaeger, like in this screenshot, and drill down and see what a policy has been doing when evaluating one request. So we have an OpenTelemetry integration with our policies, which can be used to send trace events. And like in this case, we're using Jaeger to look at a single evaluation of like pod creation, and drill down and see, what is the object that was evaluated, what are the different steps along the way that the policy took, how much time each step took, eventually what kind of log were generated by the policy, and finally what is the final outcome of the policy evaluation. By having this OpenTelemetry integration for policies, we can handle not just traces, but also metrics. And so we can have policies expose Prometheus metrics that then we can plug into Grafana, into Prometheus alerting, all the regular stuff that you are already doing with your workloads. So again, the mantra is you already have processes, tools in place for your workloads. You should be able to use the same set of tooling and processes also for policies. So last but not least, we know that this might sound attractive to you, but you might have already invested energy, time into other policy frameworks that already existed, because we just joined the space, and you don't want to bring more complexity in terms of new workloads to operate, and to in terms of resources, and also how to keep them up and running, to debug stuff and such. So taking a look at the container, at the policy ecosystem, there are two major players over there. There is Open Policy Agent and Gatekeeper. So for many people, they might be the same thing because you're writing policies using this query language called Rego. But in fact, the way that the policies are written is different, and there is a kind of fragmentation inside of this Rego ecosystem, because a policy that has been written for OPA cannot run on Gatekeeper, and vice versa, because they take different kinds of input and they produce different kind of output. So leaving that aside, you might already have some policies written in Rego. So the good news is that you can compile these policies and compile them into WebAssembly. And by doing that, you can also end up having what we call a universal policy platform. So here you can see our policy server, which is running side-by-side policies that were designed for Kubewarden with policies that are designed for OPA and Gatekeeper. So I think this is pretty exciting. And now I want to leave a stage to Rafa, who can give you some deep dive into that.
Awesome. Well, as Rafa's switching over his screen share, I have a question. We had three states. We had accept, we had mutate, and reject. And we can accept something that's coming through. We can reject it, but mutate, you allow it to enforce it. It'll accept it, but only after it changes the state of what you're trying to do to meet that criteria. Did I get that correctly?
Yes, exactly. So you accept the request, but you can also do some tuning to it. Like in the example I made, you can add some fields like the resource limits in case they are missing, or you can remove fields that you don't think are valid. And so you end up having an object, but it's slightly different from the one that the user submitted.
So it's pretty powerful where you can say, hey, instead of rejecting this pod for not having particular limits, I'll add them in there for you. and allow you to continue. So the developer or the user experience would be a lot easier, correct? I think we lost them.
Yeah, that would be correct. Maybe we have lost Flavio. I don't know.
We have. All
But
right.
yeah, that would be correct. So, for example, an example that I can think of about, meanwhile we wait a moment for Flavio, it would be adding capabilities to pods. No, you have users that are deploying pods or deploying a full stack of something, and you want to secure your cluster, and you want to do that by adding some specific capabilities to the pods and the containers that get deployed, no, on the cluster. And the users of your Kubernetes cluster don't need to do anything. You deploy the policy, and the policy would mutate the containers and add those capabilities, or remove them, or block, and so on.
That's really powerful. So we have Flavio back. Thank you, Flavio.
Yeah, sorry. Yeah, thanks, Victor, for stepping in.
Yep. Rafa, are you ready?
Yeah, I'm ready.
Awesome.
So what I wanted to show you is I have several demos to show. The first one is going to be about ingresses, and this is a story about when you have ingresses in your organization, we are going to use Cert Manager, and with Cert Manager we use annotations in order to say which is the certificate issuer that we are going to use. And so in this case, this is the annotation that we are going to block. Let's say, imagine that we have a production environment, and we have, like, for whatever reason, two different cluster issuers for Cert Manager. One is staging and the other is production. And we want to ensure that in this environment, only the production one is used, because we only want users to be presented with a valid certificate from their point of view. So this is the first example that we are going to do. This is about ingress. We are going to run it offline without Kubernetes, and then we are going to run it online inside of Kubernetes. Then the second example is about PSPs, because, yeah, Kubewarden also has policies that replace PSP. So we are going to see how that works and the policies that we created. So we are going to deploy this example inside of Kubernetes as well. And then we are going to show Gatekeeper. So with Kubewarden, you are able to reuse Gatekeeper policies that you already have written in Rigo for Gatekeeper. And we're going to show how that works also offline and inside of Kubernetes. So let's start with the first one. That is the ingress one. So KWCTL is the CLI tool that Kubewarden has for managing policies and for running them. And so one thing that you can do with KWCTL is to list your policies like you do with Docker images, for example, or Podman images. So right now I don't have any policy. And as Flavio said before, I can just go ahead and pull a policy from a GitHub container registry or any registry that is OC artifacts enabled. So I just pull that one. And if I list the policies again, you can see that we have one called safe annotations. That is the one that they just pulled. This is not a mutating policy. It's not context aware. Context aware means that a policy is able to take a decision based on more information from the cluster, not only on the request that it's evaluating in isolation. Also, we can get a sum of the policy itself and the size that it has. And so one thing that we can also do is to inspect it because the policy has metadata embedded in it, and this is not even related to the OCI distribution or anything. This is not even on the registry. This is on the binary of the policy. So if you copy this policy over, or you send even this binary through email or through Slack, this will fly with the policy. So this is metadata that goes with the binary, and you can see some information about it. You can see what kind of resources it focuses on. Since this is about safe annotations, this is a very generic one. It's not focusing on anything because it can work on any kind of resource on Kubernetes. And then you can have even some documentation on how to use it. So now let's look at one request that I recorded from the API server. And in this case, we are going to try to create an ingress. And as you can see on the annotation part, this one has Let's Encrypt production and is the one that we actually expect, right? So this one should be fine. And so we are going to try to evaluate the request offline. Again, with KWCTL, we are able to do this. We don't need Kubernetes for this. And so what I can do with KWCTL run is to pass what settings I want to provide to the policy. In this case, this policy gets constraint annotations that I'm able to set on the command that I'm running. I can say the path to the request that I recorded, and then I want to run this policy. And so I can do that. And then I can see that KWCTL returns to me what the policy resolved, that is, that it's allowed. And in this case, let's look at another request that in this case is let's encrypt the staging. So in this case, this should not work. Let's try to evaluate that with the same arguments. And now you can see that, in fact, it failed, and you get this error that comes from the policy. So the policy is also able to get you this error for you. And so now let's go ahead and try to do this, but on top of Kubernetes. So what we are going to do here is basically pull the policy again. Every time I run this, I'm running this live, but every time I run this, this gets cleaned. So I pull the policy again just to run KWCTL manifest. You don't really need to run this command, but it helps you because it generates a scaffold for you. So it's not really, as I said, it's not really required, but it's helpful because you can just get a scaffold that you can then edit. So in this case, I'm going to run KWCTL manifest. And we are going to create a cluster admission policy. Right now, this is the only type of resource that we have because we only have admission policies that are cluster wide. We are going to add namespace ones, but this is not the case right now. And now I add the settings as well here as I did before, and then I just generate the YAML with this. And so as you can see, this is what was generated. Part of it came, the rules, for example, came from the metadata, also whether it's mutating or not. But in this case, through the settings JSON, I provided part of it that got filled from what I said on the CLI. And so now let's try to just create this on top of Kubernetes, basically running the same command, but piping that to kubectl. Okay, so now it's created. And now we are just going to wait for the policy to be active. And so let's wait for some seconds, and it should be. This is actually waiting for the controller to put everything into place and for the validating webhook to be registered. And so now let's see an ingress again with the Let's Encrypt production one. So this should be fine. Okay, and this was created without any issues. And now we look at Let's Encrypt the staging one. So this one should be rejected on top of Kubernetes. And yeah, as expected, this was actually rejected by our policy. So, okay, this is cool. Now we have this ingress example that was made up, but could be a real life case. And now we are going to look at PSPs. So for example, let's look at one that disallows host namespaces to be used on pods. And so for that, I can go and let me try to see if I can change what I'm sharing. Okay. Okay, so now you should be seeing my screen. So what I did now is I'm looking at the policy hub. This is where we have published some policies. And so you can look for example, for namespace. And in this case, we have provided one policy that replaces part of the PSPs. So in this case, what this allows you to forbid is what kind of namespaces from the host you are able to use on pods. And so by default, and this depends on the policy, but in this case, all of them will be false. So you cannot, if you deploy this policy and you don't provide any settings, for example, you could say that you just want to allow host network. In this case, you would provide the settings with allow host network true. But in this case, if you don't provide anything, all of them will be rejected. And so with this, we are able to restrict what kind of things we are able to create in terms of PSPs, in terms of pods. So let me stop sharing again and share. This one. Okay, so now let's go ahead and run this example. We are going to pull the policy that I just searched for on the Kubewarden hub. And now we are going to apply that to deploy the policy. And now let's wait for the policy to be active. Again, in this case. Again, this is doing order reconciliation. And now let's show a pod that has host network true. In this case, this is what I want to forbid. This, as you can see, this one, I'm going to forbid this just on the, for every namespace that is not the kube system one, because this is the way in which I'm deploying this policy. And so in this case, if I try to apply this, this is rejected by the policy. And now I'm going to try to create this, but in this case, as you can see, the namespace is kube system. It's also host network true, but in the way that I deploy this policy is only applying to all namespaces except for kube system. And so with this, I'm able to actually create that one. And yeah, it was already created. Sorry for that, but yeah, it's able to create that. And so if I show the host network pod policy, 1 second. Host namespaces policy, this one. This is the way in which this was created, because I didn't show that on the demo itself. So you can see that the settings I provided this allow host network false. This was not needed, as I said before, because this is the default already. So if I wanted to allow it, I could have provided true here, but it doesn't really matter. And this is a cool thing, because in this case, there are many times in which we want to allow something on the kube system namespace, for example, or on other namespaces, but we want to forbid this on the rest. And so we can use the namespace selector that will be forwarded to the webhook itself of Kubernetes, and we can say that the namespace itself is not in kube system. As you saw before, this is rejecting the pod that was tried to be created on the default namespace, but not on the kube system one. And so now that we saw that, let's look at the last example. That is, let's say that you imagine that you already have learned about Rigo, about Gatekeeper, OPA, and you already invested time and efforts in that. So the good thing is that with Kubewarden, you're able to reuse all that work. And so if I run this example, we are going to show a policy. I don't want to get too much into the details, but this is a Rigo one. And so there are two ways in which you can violate this policy. One is by missing a label completely, and the other is because the label is not matching, the value of the label is not matching whatever you provided to the policy. And so let's build it, because as Flavio showed before, we have to build the policy to WASM, but we just need to use the OPA build command that is from the official CLI tool from OPA. So nothing strange there. We have to extract the policy because it generates a tarball. That's fine. And this is just the WASM file. And so we are going to look at deployments in this case. And what we are going to enforce is that they have an owner team label. So everything that we are going to try to deploy needs to have an owner team. Otherwise, it will be rejected. And so in this case, we can see that we have a label owner team, some team. And in this case, this is fine. And so let's try to run it. This is, as you can see, the spite is is based on OPA and Gatekeeper is the very same thing. We provide settings over here, and we have to specify, because we didn't annotate this policy, we have to specify that this runs in Gatekeeper mode. But if I had annotated the policy in that it says it's a Gatekeeper one, then I wouldn't even have to provide this argument here. So I provide the path to the request, and then I just run the policy. So in this case, this is a load, as we expect. And now let's show a request that is not valid because it's missing the owner team label here. And so let's just run it. Let's run it offline. And you see now, you must provide labels owner team. This error is coming from the Gatekeeper policy. And now, just for completion, let's try to run this on top of Kubernetes. And so let's apply this one. Let's wait. It's this very same thing. As you can see, it's exactly the same thing as a user from a user point of view. There is nothing to learn there. So we see that cluster admission policy is active now. And this one is valid because it has the owner team, some team label. So let's try to create that one. Okay, this was created. And now let's show one that is missing, this deployment is missing the owner team label. So let's try to create that one. Yeah, and we can see that this is now running on Kubernetes, and this was a Gatekeeper policy and is rejecting the request. And this is all from the demo part. So yeah, hope you enjoyed it.
That was really great, Rafa. You showed
Yes.
quite a lot of stuff. I mean, it was pretty packed. So just to give a summary, if you are someone who is comfortable writing policies, you can write them using regular programming languages, or you can keep using Rego if you want. If you're not, a seasoned developer, you're not really comfortable with that, you can go to the policy app and find policies that have been created by the community and shared over there. Then you can consume them. And the KWCTL tool that Rafa showed many times, it can be easily embedded into CI/CD pipelines. So if you are into GitOps, which is pretty cool, I think, as a way to manage clusters, you can wrap KWCTL inside of one of your pipelines so that you can, for example, run some policies against workloads definitions that are not yet committed into Git repo yet, or you can, use KWCTL to run the policies, test them from time to time to make sure that, they're catching all the things that are supposed to prevent from happening. And I found also nice, the OPA example where you have shown that, with the same set of toolings and the same paradigm, you can deploy a policy that, was written in Rust and another that was written in Rego. It's the same stuff. Rafa didn't show that, but you can push the Rego policy to an OCI registry as well. We just didn't have that around, or maybe you had. Sorry, maybe I missed that.
It's actually one of my registries, yes. It was pulled from one of my registries.
Yes. Yeah. So
I have a question real quick.
That's perfect. We are in Q&A time.
Yeah, I love Q&A time. We should make a Q&A time anytime, but Rafa was just flowing there. We see a very solid use case for using this in production or development, but when you're a local developer, correct me if I'm wrong, is there a use case to kind of mimicking that you can actually mimic those, corporate policies locally so you don't kind of go out of bounds to that? And this is an easy way to do that, right?
Yeah, definitely. You're spot on, Robert. So as sort of a development cycle, you can test your policies many ways. Given that the policies are regular programming languages, written using regular programming languages, you can do unit testing using the frameworks of the programming language of your choice. But you can also use KWCTL and run the final WebAssembly module, the policy, against some input. And we haven't shown that, but if you ever use BAT, which is like a unit testing framework for for tools written in Bash, you can then use bat to drive testing of your policies through kwctl. And also, it's nice for operators. kwctl is nice because you find a policy and you try it out, you experiment that outside of the cluster, you keep fine-tuning that to find the right set of values to configure that, and then you scaffold and push into your cluster.
All right, so we have some couple other questions coming in here. We talked about the cluster admission policy, a resource that defines the policy as being cluster-wide. As a K8s operator / administrator, can I segregate policies per namespace?
Rafael,
yeah,
you want
totally.
to?
Yeah, you can totally do that. Despite the cluster admission policy is a cluster-wide resource, you can segregate policies per namespace, not policies, but what the policy targets. So you can do that. What we want to do is to introduce in the future also admission policy that is not cluster-wide, is namespace-wide. So we could say that your teams within your company can create their own admission policies that are namespaced and that can only target things inside of that namespace. And so they can kind of self-service their own needs, right? So maybe one team has different rules than others, and they want to enforce something within their team, so they are able to do this.
Yeah, exactly. Right now, I mean, the policies are pretty powerful and hence dangerous, and only selected people inside of a cluster are meant to modify them. So cluster admission policies are meant to be used only by trusted admins, but with introduction of namespace local cluster policies, then it's going to be safer to hand over the control of this kind of policies to some other users.
Now, I got an opportunity to speak about building policies in Rust, and I've gotten to take a deeper dive into actually writing a policy in Rust for Kubewarden. But it drew more questions out whether it's possible to have a policy that enforces that you have policies in it. And so the question kind of arises, can I have a policy to ensure that a namespace or a cluster has all the policies I want set, and not to allow anything until those particular policies have been met? Have you guys thought about enforcing that? Because, as you look at it, we're going to have more than one policy, right? And how do we ensure that all of those are there as we're, going through, or we're spinning up a new environment? And GitOps is a big thing right now where, are we making sure those policies are active? Is that something you guys have thought about?
I haven't thought about that, so thanks for bringing it up. So right now, the answer to the specific problem, at least to me, is to, as Robert hinted, is to do GitOps. So use something like Fleet, for example, and declare inside of the Git repo all the different definition of cluster admission policies that you want to have enforced, and then just rely on Fleet to propagate that. I don't know what the others think about that.
Yeah, I agree with that. I mean, in the end, it's just regular resources, right? So in the same way that you are deploying other resources to a number of clusters, you can also enforce cluster admission policies in the same way.
Awesome. So one of the next questions we have is, so the policies that are enforced by Kubewarden, can Kubewarden itself be checked with its own policies? It's an interesting one.
Rafa, do you want to?
Yeah, I guess this means that if it can check that it has other policies like deployed, or
I think it means, like, let's say that we don't want to have any kind of pod running as privileged. Can I declare a Kubewarden policy that does that, and make sure that also the Kubewarden pods are respecting that?
Yeah.
And if that's the question.
Yeah. Sorry, I got it wrong. Yeah, so absolutely. In the end, Kubewarden is deployed as another workload instead of your cluster. So it would be possible for Kubewarden to check itself to some extent, because you have to be careful of not getting into errors in which Kubewarden might be rejecting its own pods, for example, because of whatever reason, because you introduce some new limitation, whatever, inside a new policy. So it's possible, but you have to be careful about it.
Yeah, generally speaking, policies, admission controllers are pretty powerful, and so you have to be really careful when you handle them. As Rafa showed into the demo, you can target a specific namespace for a policy to be effective just inside of this namespace. For example, if you want to prohibit pods to have to use the host network, this is a pretty legit requirement. But if you enforce that cluster-wide, then you're going to break your CNI drivers, because they have to run in this mode. And so it's always important to reflect and be careful about where policies are going to be applied, enforced in terms of namespaces and such.
So I get this question on a lot of these episodes that I get to put on. So I'll ask it, because no one else did. What's on the roadmap? What's next for Kubewarden coming up?
So we are currently working on integrating SigStore inside of Kubewarden. I know many of you are familiar with SigStore. SigStore is a project in the space of secure supply chain. So what we want to achieve here is, first of all, we want to provide a way for our end users to make sure that the policies that they are about to deploy, these policies can be trusted, because they have been signed by a trusted policy author, and nobody tampered with the policy. So that's the first thing we want to achieve, and we are doing good progresses on that. The second thing we want to achieve is to expose SigStore functionalities to policy authors. We will also provide a policy which leverages that, so that we can write a policy that makes sure that all the container images that are deployed inside of a cluster, they can be verified using SigStore, so that you can allow only trusted workloads inside of your cluster. So this is one thing we're working on.
So there goes the days of, I just pulled it from Docker Hub, someone pushed it up there, and those can be long gone, right?
This is already long gone. If you want, you can go to the policy hub, and we have a policy that can reject images coming from registries that you do not trust. But this is even more, So you can say, I'm fine pulling from, let's say, the Docker hub, but I just run images that are signed by someone that I trust, for example.
So it's literally an extra layer on top of that.
Yes, exactly.
Awesome. We have a couple polls up. If you haven't answered the polls, please feel free to do so. Click on the poll button on the bottom. There's 2 in there. We'd love to get some of your feedback. Guys, what's some of the next steps?
Another next step, or
I think there's the next slide goes to we should have.
Yeah, sure. So we have to wrap up, but I think the next steps are, go ahead and give a try to Kubewarden, unless you have already done. Visit GitHub and give some star to us. It's a bit complex to give stars to us, I have to admit, because we have so many repos. There's so much choice. So just star all of them. No, I'm joking. There are many repos you will see. And it would be great to stay in touch with you, to exchange feedback and such. So we have a Slack room on the Rancher user Slack space. Join us over there, and let's keep talking. It was really nice to have these questions and to do this exchange with you.
Yep. Now, if I actually got to go through all of it, so I've gone through the documentations, and I got to meet up Rafa quite frequently on things that I didn't understand, but I got through it. And if you have an opportunity to go through and write your own policy, it's not as hard as you might think. Rust is not a very forgiving language, but it's one of those where you can. I do have a GitHub repo myself that I kind of walk people through building your own policies, and I follow the same documentations that are out on GitHub in the documentation site for Kubewarden. So if you want to do it from that aspect, but if you follow it on the other aspect of things and you're just an operator and want to deploy one, it's literally 4 commands from a terminal, and Kubewarden is deployed, and then 2 more to actually deploy a policy. So it's really easy to get started, and the documentation will walk you through it. So if you're kind of like, it's going to be too hard, trust me, it's very easy. All right. Oh, got another couple questions coming in here. So Kubewarden is checking all the resources that get created, updated, etc. in the cluster. Does it need much resources? What is the latency that Kubewarden adds? And that's a good point, because if you're on a development machine, you throw Kubewarden on there, is it going to take the machine down, or is it heavy?
Mm-hmm. So that's a fantastic question. So in terms of the architecture of Kubewarden, first of all, we are, let's say, pretty selective in terms of the events that we process. There are other projects which act as a sinkhole, so any kind of request going into the cluster has to be evaluated by this admission controller, even though there is no policy interested in this kind of event. On the other hand, so that means that there is latency introduced to any kind of operation happening inside of the cluster. We are pretty surgical when it comes to registering our policies, and so we receive events that are only the ones that are pertinent, relevant to the policies that are currently loaded. And so in terms of performances, and what I can tell you is that we did some benchmarking, and with just one policy server instance, like one process, we were able to process 1,700 requests per second in a pretty short amount of time. We should actually, that's a question we got asked pretty often. We should, update the docs with data. But on top of that, we also have more flexibility. So we have shown today only, the cluster admission policy custom resource. We have another custom resource, which is policy server. So by default, when you deploy Kubewarden, you will have one policy server object declared inside of your cluster, and this is a deployment which has a replica size which you can grow and shrink according to the amount of processes that are done on your cluster. What you can also do is create other policy servers, so other deployments, and you can cordon policies. And for example, you might have, let's say, a tenant on your cluster which is generating a lot of events, and it's kind of slowing down the evaluation of the other events of other tenants. So in that case, you could, for example, declare a policy server object just for this tenant, which is going to have its own replica set behind, which can be like 5 nodes because it's a massive tenant. And then all the requests about this user are sent to this policy server deployment. And so this is great for distributing the load, but it's also great for availability. So we are already HA with a single default policy server, but you can make that even better by creating other policy server, and let's say put all the mission critical policies in a limited on a dedicated policy server deployment, and leave the other together in another one. So it's pretty flexible.
One other question that we have here is there any plans of integrating Kubewarden to Rancher? And I think the question kind of lies where is there going to be kind of hey, I can see what policies I have active in Rancher and just have one single pane to manage that?
Yes, we are currently working on that. So we are going to extend the Rancher UI to manage also Kubewarden to give a simplified control plane for managing the policies you have, for deploying them, for seeing what is going on with them. So stay tuned for that.
Awesome. Any more questions from the audience? I think we're at the top of the hour. check. All right. Well, I think we got them answered. Gentlemen, I want to personally thank you guys all for being here. Meant a lot for us in the community, for everyone who showed up in the community. Thank you for coming. This video will be posted on YouTube sometime later today. I got to do the post edit on it, make sure all of our audio comes through loud and clear. You want to check out more, it's kubewarden.io. If you want to learn more about the community, it's community.suse.com. And I think we're going to have this slide deck prepared in a PDF, and we'll drop that into our events section of community.suse.com around this event. So you guys can go and click on those links and take it from there. So everyone on the call, thank you very much, and we'll see you guys next time.